Welcome back to The Explainer. Today, we're going to demystify a really core concept in C++. We're talking static members. Think of it like a central scoreboard for an entire class, and that's the kind of power we're unlocking.
All right, let's kick things off with a classic programming puzzle. You know how every object in C++ is kind of its own little world, right? It's got its own data, does its own thing. But what if they all need to share a single piece of information? How do you handle something that belongs to the entire group, not just one individual?
Okay, let's make this less abstract. Say you're building a system to manage students. Easy enough. But you're probably going to need a running total of every single student record you create, just a simple counter. But where would you even put that counter? It doesn't belong to any one student, it belongs to the whole class of students. So how does C++ handle this? Well, it has this really elegant solution. And the first part of it is something called the static data member. Okay, so what is that exactly? Basically, a static data member is a variable that is shared by all objects of that class. It's not personal property for each object. Nope, it's that central scoreboard we were talking about. One score for the entire team. Now, these things have some really specific rules, and they're super important. First off, there's only one copy of it for the whole class. Just one. It's also initialized to 0 automatically for you, which is handy. And its lifetime, it sticks around for the entire program run, not just as long as one object is alive. And here's the kicker, the one that trips people up. You have to define it outside the class definition. We'll see exactly what that means in a bit. Okay, so we've got this shared scoreboard. Great. But how do we actually use it? How do we read the score or update it? You can't just ask one of the objects because remember, it doesn't belong to any of them. We need a special tool for the job. And that brings us to part 2 of the solution. The static member function. Yep, you guessed it. It's a function that also belongs to the class as a whole, not to any single object. It's basically the designated scorekeeper for our class scoreboard. So here's the deal with these functions. Since they don't belong to a specific object, they can only access other static members. It's like a statics-only club, and that leads to their coolest feature. You can call them directly using the class name itself. You don't even need an object to exist yet. And here's how you do it. The syntax is super clean. It's just class name, then the scope resolution operator, that's the double colon, and then the function name. Boom. It's a really clear way to say, hey, I'm doing something that affects the entire class. Okay, enough theory. Let's see how this all works in practice with that student counting example from our source material. This is where the magic happens. So first things first, inside our student class, we declare our counter. See that static keyword right there? That's the signal to the compiler that this object count is the special shared one we've been talking about. And of course, to go with our static data, we need our static function. We'll call it showCount. And because it's also static, it gets the special permission it needs to access our static object count. Now, listen up, because this next part is super important and a really common gotcha for people learning C++. Our source material nails this. You have to define the static variable outside the class. The declaration inside just tells the compiler, hey, this thing exists. The definition outside is what actually sets aside the memory for it. And this is what that looks like. It's just one line. Outside the class, you have the type, int, then the class name, and the double colon, student, colon, and finally the variable name, object count. That's it. That one line is what brings our shared counter into existence. Okay, so let's jump into main. We create our first student object, we'll call it S1. Now to check the count, we don't do something like s1.showCount. Nope. We call the function directly on the class, just like we learned, student showCount. And the program just keeps going. It'll create another student, S2, and check the count, then a third, S3, and check the count again. And every time a new student is created, its constructor is secretly ticking that shared counter up by 1. So we should see the number climb, right? So the big question is, after all that, does it actually work? Let's look at the output. And yes, it works perfectly. Check out the program's output. After the first student, the count is 1. After the second, it's 2. After the third, it's 3. Our shared object count did its job exactly right, keeping a perfect tally. So you might be thinking, okay, that's a neat trick for counting things, but what's the big deal? Well, this is huge. It's a core pattern for managing anything that needs to be shared by all instances of a class. I'm talking about things like shared resources, or maybe a single connection to a database that every object needs to use. It's incredibly useful.
And that kind of brings us to a final thought. Now that you know how to create this shared, class-level scoreboard, what else could you do with it? What other kinds of class-wide data could you manage? Think about it. The possibilities are pretty cool.